Hi, in this video we are going to talk about oscillator. What is oscillator? An oscillator is basically a circuit that takes in DC input and convert it into an AC output. Now the output can be sinusoidal nature. You can get a sine wave, also known as a harmonic oscillator, or you can get a non-sinusoidal output. So these would be classified as a relaxation oscillator. You can get a triangle wave, you can get a square wave, and you can also get a sawtooth wave. So an oscillator consists of two main parts, an amplifier and a feedback network. So the feedback network is in this illustration, is indicated by beta, and now the amplifier increases the voltage of the circuit. So let's say this represents the voltage, this would be the output voltage. The output voltage of the amplifier is equal to the voltage gain times the input voltage V in, and now the feedback network is attenuation network. It reduces the voltage going from the output back into the input. So beta is the attenuation factor. So as some of the energy goes back to the input, we get a voltage called Vf. Here Vf is equal to the attenuation factor beta times the output voltage V out. Now in order for the circuit to work, the feedback network must provide a signal that is in phase with the input signal. So the amplifier provides a 180-degree phase shift related to the input signal. You can see that these two waves are 180 degrees apart. Now the feedback network also provides another phase shift which is 180. So what happens is that it's going to be in phase with the original output signal, and this leads to sustained oscillation. So we add these two angles, 180 plus 180 equal to 360 degrees, and so that Vf, the feedback voltage, will be in phase with the input voltage, and so you could see the cycle once the circuit is given the trigger pulse. Let's say if you connect the power supply to the oscillator, the signal at the output is fed through the feedback going to the input of the amplifier. It gets amplified, comes back out of the output, and the cycle continues. Now we have time to determine the loop gain of the circuit. So if we replace the output voltage with what is equal to here, we will get Vf is equal to beta times the voltage gain times the input voltage V in. So the ratio of the feedback voltage is Vf over V in is equal to beta times AV is the product of the attenuation factor and the voltage gain of the amplifier. So in order for the oscillator to function properly, two conditions must be met. The first one is known as the Brock-Hansen criterion. That is when the attenuation factor times the voltage gain is equal to 1. So the loop gain of the oscillator network must be equal to 1 in order for us to have a sustained oscillation. And we already mentioned the other condition is that the total phase shift must be 360 degrees in order for positive regenerative feedback to occur. Now let's talk about what would happen if the loop gain is less than 1. So if the loop gain is less than 1, oscillation will occur initially, but eventually is going to die out. And so dampen will occur, and now what happens if the loop gain is greater than 1? Okay, the oscillation will occur initially, but then it will get larger and larger. Eventually they will reach a ceiling where clipping will occur, and because there's only so much that the DC power supply can support. one. Now there's two common oscillators that you will come across, LC and RC circuit. Typically for LC circuit you have inductor connected in parallel to the capacitor. Now as energy is applied to this network, the capacitor absorbs the energy as it stores in its electrostatic field, and the capacitor releases the energy into the inductor as it discharges to the circuit, and the inductor stores that energy in its expanded magnetic field. When the magnetic field of the inductor collapses, that energy is used to charge the capacitor. So energy is transferred back and forth between the capacitor and inductor, and thus the circuit will generate a sine wave as the energy cycles back and forth. The frequency of the oscillator can be calculated using the formula. It's 1 over 2 pi square root of L multiplied by C. Now for RC oscillator, we use a capacitor and also a resistor in this network. Now with this type of circuit, the frequency is usually some variation of this formula, 1 over 2 pi times RC. The two common example of RC oscillator circuits include the RC phase shift oscillator circuit. That's one of them is a wide bridge oscillator circuit, and also the 555 timer. Of all of these simply use resistor and capacitor to generate the oscillator circuit.